Okay, we are discussing about organocopper compounds. Okay, so more particularly Gilman reagent. So Gilman reagent means dialkyl lithium cuprate. So, more particularly, we discussed about the substitution reactions of organocopper compounds. So now let's look into the 1,4 addition reactions. 1,4 addition, or also it's called a conjugate addition. Aldehydes and ketones do not react with the Gilman reagent, but they can react with alpha beta unsaturated aldehyde and ketone. So what it means? It means that uh, organocopper compounds does not react with the carbonyl carbon, but they are react with the double bond, which is conjugated with the carbonyl carbon. Okay, so let's look into that. So this is a carbonyl carbon. So this one is called carbonyl carbon. And this is called a hard electrophilic center. This is a sp2 carbon atom, and this one is called soft electrophilic center. And here a lithium organolithium, magnesium, okay, organolithium and organomagnesium attack this carbonyl carbon, whereas the organocoppers attack only this fourth position. This is 1, 2, 3, 4, fourth position, and this is called a soft electrophilic center. Okay, so here I am taking an example. Uh, uh, what you call it's an alpha beta saturated carbonyl compound. So this is diethyl lithium cuprate. So there will be a new bond formation between this carbon and this soft electrophilic center of alpha beta unsaturated carbonyl compound. So there will be an intermediate formation like this. So that means C2Hy or CH3, it will form a bond here, and intermediate is obtained like this. And this intermediate, what will happen on hydrolysis? This intermediate on hydrolysis. Hydrolysis means this bond pair can come over here, this bond pair can pick up a proton. So what is the compound obtained? The compound obtained is enol. This is enol. So usually enol is the tautomeric form of ketone. So what it will do? It will convert into a ketone. How it will convert? The bond pair can come over here, and this bond pair can pick up a proton. So that is how the compound is obtained. So with this, I will go to the next slide. So here I am taking one more alpha beta unsaturated compound, but here two double bonds is there. This is one double bond, this is another double bond. Double bond in the sense conjugated one. This is one conjugated, this is another conjugation. So here you can observe that there is a steric hindrance, but here this particular side there is no much steric hindrance because H is there. So that is the reason ethyl group or the methyl group attack this particular carbon, so forming a compound like this. So in these two examples, this is the one. Ethyl I am taking. So here I'm added as a CH3. You can change this one or this one. Okay, that correction you need to make. So in this case also, Here I am taking ethyl, but here I am substituted as a methyl. So you can change either one, this one or this one, you change it. So this is about what is called 1,4 addition. So here I am taking one more example. Methyl, this is the methyl one. So this one attacking this carbon, not this carbon. So I mentioned usually organolithium and organomagnesium compounds attack this carbon, carbonyl carbon, whereas this carbon is attacked by copper, okay, organocopper compounds. So what you can observe here, there is a possibility, okay. I think with respect to these two, this is towards the observer, this is away from the observer. Towards the observer and away from the observer means trans one. So trans product is more formed, major product, and cis product, both the groups are away from the observer, is the what is called as cis and cis is the minor, means less quantity product is obtained. Suppose a group called, what is this group? Isopropyl group is attached to the conjugated, near to the adjacent to the conjugated double bond. So then methyl group will attack here. So here the major product obtained itself is a trans, but there is no cis in this case. And I will go to the next one. So look here, I am taking, what is this? Isobutyl group. This isobutyl, diisobutyl copper lithium, it will act as a source of isobutyl that will attack this carbonyl carbon. And this bond pair can go over here. And this bond pair will sit on this oxygen. So what it will do, this anion, suppose if there is a electrophile is present, electrophile like trimethylsilyl chloride. In that cases, there will be a new bond formation between this oxygen and this silyl, and chlorine will go out. So that is how a compound is obtained. And this on hydrolysis means breakage of this one, giving rise to this product. So what it means? It means that 1,4 addition of organocopper compounds followed by treatment with electrophile. So if it is a silyl, it will form a bond like this, O silyl bond. If not, if it is a alkyl halide, then this bond pair come over here, and here there is a one double bond that you need to remember. Okay, here there is a double bond, okay, because so when this bond pair is attacking here, this bond pair is going over here. That means here there is a double bond, and here also there is a double bond. That means enol. Here also enol is obtained. This enol may be converted into ketoform in a ketoenol tautomerism. So here in this slide, this double bond is left over. Maybe you can rectify. Here also double bond is there. Here also double bond is there. So with this, I will go to the next slide. So here I am taking reaction with conjugated acetylenic ester, conjugated acetylenic esters. So here triple bond is there, and also it's an ester. What will happen here, as usual? Okay. Here also something is left over. There will be a new bond formation between this carbon and this carbon. So what will happen when the nucleophile is attacking here? This bond pair is going over here, and this bond pair picks up a proton. That means there is a double bond here. So that means allene. alene kind of thing. Here one double bond is there, and this is isobutyl group is there. And this on hydrolysis. So this can fix up a proton. But here there is a double bond, alene kind of thing. And later on, this enol can be converted into ketone, but here there will be a double bond. So you need to correct it. So how you can correct? You make one double bond here, alene. You also make one double bond here, alene, and here one double bond, which means alpha beta unsaturated ketone is the product. And one more thing, cyanocuprate, higher order cyanocuprate. So this higher order cyanocuprate is nothing but a reaction of organolithium with copper cyanide. Copper cyanide means cuprous cyanide, CuProus, cuprous cyanide. So what will happen? There will be a complex formation like this, and this particular complex is more stable one. Only the small excess of reagent is enough. So whereas in the case of Gilman reagent, more amount of reagent has to be added. So this particular one is less quantity is enough to act as a Gilman reagent, whereas the Gilman reagent require more quantity of the reagent. That is about the advantage about cyanocuprate or the higher order cyanocuprate 1. So this is about what is called as organocopper compounds. So up to this, we discussed about the unit called organometallic, use of organometallic in organic synthesis. So I think we discussed about organoselenium, organosilicon, organocopper, organomercury, okay, organolithium, okay. All these reagents are useful in organic synthesis. So maybe we will. Here I am giving a few questions which were asked previous year questions from the university question paper. So usually Simon-Smith reaction. So what is Simon-Smith reaction? Explain with an example. So this is about what is called as insertion of carbon to a double bond. That means cyclopropanation reaction. So here what is Simon-Smith means iodo-methyl zinc iodide. Okay, iodo-methyl zinc iodide is nothing but a Simon-Smith reagent. So that when it is reacting with the double bond, cyclopropanation occurs, and that reaction is called Simon-Smith reaction. So you have to take an example and you have to explain. What is Gilman reagent? So dialkyl lithium cuprate is called a Gilman reagent. So you have to give the method of preparation of Gilman reagent. That means cuprous iodide, when it is treated with organolithium, Gilman reagent is obtained. So predict the product and write the mechanism. So here it's a general mechanism you need to write. You need to write the general product. What will happen? R2. R2 means dialkyl copper lithium. So there will be a new bond formation between this alkyl group and this carbon. So once there is a new bond formation here, this bond pair is come over here, and this bond pair will sit on this oxygen. And later stage, this bond pair can come over here, and this bond pair can react with this R2, R1. So that means the product will be R2 will be substituted here, R1 will be substituted to this carbon. That will be the product. And predict the product and write the mechanism. This is about the organosillyl compound. So organosillyl compound converts this acetal, okay, removal of these R2 will go out as a R2 iodide. Okay, and O will go out as a trimethylsilyl oxy, means bis trimethylsilyl oxy. And what is here? There will be a formation of ketone. Since it is R and R is there, so ketone will be the product. So breakage, ether breakage, that's achieved by trimethylsilyl iodide. You need to write the mechanism. And here predict the product and write the mechanism. So what is this trimethylsilyl? Trimethylsilyl react with AgCN. So what here the question mark? The question mark will be trimethylsilyl cyanide. Trimethylsilyl cyanide, when it is added to aldehyde aldehyde, what will happen? There will be a new bond formation between the cyano group and this carbonyl group. And there will be a new bond formation between the oxygen and then silicon. So that will be the product here. Then how do organolithium compounds react with imines? So organolithium, how they react with imine and nitriles and also isonitriles. So here you need to write what are the products obtained when organolithium reacts with imine, okay, and nitriles and isonitrile. I say this I have given, you just look into the notes. Illustrate how the following compound can be synthesized by Simon-Smith. So that means here compounds I need to give, maybe I will include. Means here you can take any Simon-Smith products. Okay, Simon-Smith products, how these are obtained. Yes, Simon-Smith products you need to write here, and you have to explain how the Simon-Smith products are obtained, more particularly synthesis. So that means you just explain about the Simon-Smith reaction. So illustrate any two methods of preparation of reactions of tri-N butyl tin hydride, a reducing agent. It will act as a reducing agent. It will act as a source of hydride. And more particularly, you have to two methods of preparation, how the tributyl tin hydride is obtained. Okay, two methods of preparation you have to explain. Write a note on use of organolithium reagents in organic synthesis. So organolithium reagent means maybe you can take any one. So dialkyl lithium, dialkyl aluminum hydride, its preparation and application, or maybe a trialkyl aluminum hydride, its preparation and application, alkynyl dialkyl aluminum hydride, its preparation and application. So those any one or all the three you can write and write two application. So that's enough for that. And so with a suitable example, give the synthetic application of organomercuric compounds. So organomercuric compounds means Hg, okay, carbon Hg compounds. So how the carbon Hg compounds are prepared, how these are useful. Maybe you can say about the electrophilic substitution reaction. So more particularly, you can also explain about the mercuration and demercuration. And more particularly, you can also explain about the solvomercuration. Solvomercuration means mercuration as well as solvent will form a bond with a double bond. So that also, those examples also you can take it. So complete the following with mechanism. So here the two double bonds, this is one double bond, this is another double bond, okay. So only one double bond is attacked by R3 as well as aluminum. It's an example of carboalumination. R3 will add to one carbon atom, okay, and aluminum will add to terminal carbon atom. So then on treatment with H plus, aluminum is replaced with H. That's what you can mention as the product, and also you can write the mechanism. And then write an account of the use of lithium dialkyl cuprate in organic synthesis. So lithium dialkyl cuprate, maybe you can explain about substitution reaction, and you can also explain how the lithium dialkyl cuprate is synthesized, substitution reactions, and 1,4 addition reactions. Those things you can explain, and it is for the 4 marks question. Then illustrate any two methods of preparation and the reactions of tri-N-butyl tin hydride. So reactions, it's that means two methods of preparation and the reactions of tri-N-butyl tin hydride you have to write under this question. How are the cyclopropanation of alkenes brought about using organometallics? So that means cyclopropanation reactions, right? Organozinc with organozinc, more particularly Simon-Smith reactions. Okay, using that you can brought about the cyclopropanation reaction. Then how can the following conversions be brought about using organoselenium compounds? Okay, organoselenium compounds. So organoselenium compounds means carbon Se selenium compound. How the carbonyl compounds is converted into alpha beta unsaturated carbonyl compounds. That means a carbonyl compound, when it is treated with base, alpha carbon attains a negative charge. That negative charge, when it is treated with phenyl silanyl chloride, there will be a new bond formation between the alpha carbon and selenium compound. And with that selenium compound, when it is oxidized with the sodium hydroperoxide, SeO is formed, and then SeO undergoes rearranges, involves a concentrated reaction 6 electron system, and there will be a double bond formation. That double bond is nothing but a alpha beta unsaturated carbonyl compound formation. And how the alkyl halide is converted into alkenes. This one also you need to explain. So prove with the example how tributyl tin hydride behaves as a reducing agent. That means it will act as a source of hydride. So hydride will add to one carbon, and oxygen will form a bond with tin. Okay, more particularly you can explain about the mechanism, what happens when carbonyl compound is treated with a tributyl tin hydride. More particularly, you can take AIBN as a radical initiator, or maybe in presence of light, it will give you the product. Write a note on organo-aluminum compounds in organic synthesis. Write a note on organo-aluminum compounds in organic synthesis. Again, aluminum compounds means dialkyl aluminum hydride, or trialkyl alane, and alkynyl dialkyl alane. So anyone you can take and explain. And illustrate the methods of Peterson reaction. So Peterson reaction, so usually you can expect one question on this Peterson olefination, how the double bond is formed. So more particularly, you have to take about the eclipse form, and then you have to show the syn elimination, and you have to show the how the double bond and the syn product is obtained. That you have to tell. And so there will be one question on Peterson olefination. And then with a suitable example, give the synthetic application of organomercuric compounds. Organomercuric means salvomercuration, mercuration, demercuration. So these points you can explain. Right. And then here, the first one I have written as a organomercury compound. Second one also I am written as a organomercury compound. Maybe you can retain one. Another one, maybe you can change it as a copper, organocopper compounds, organo-zinc compounds. So write a note on the use of alkynyl dialkyl halenes in organic synthesis. So it's a direct question on alkynyl dialkyl halane in organic synthesis. So mention any one method of synthesis or the preparation and give the reactions of organoselenium compounds. So carbon Se bond is called organoselenium compound. So you have to give the method of synthesis, and also you have to write the application of organoselenium compounds in the alpha beta unsaturated carbonyl compounds and also in alkene preparation. And then justify tributyl tin hydride behaves as a reducing agent statement with an example. So with an example, we have to uh, 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 give a reaction as well as a mechanism where there is a application of tributyl tin hydride. Okay, so let's give an entry. Okay. Then mention any one method of synthesis or preparation of give any one method of synthesis or preparation and give reactions of organoselenium compounds. So that means you need to mention how the organoselenium is synthesized and how these organoseleniums are useful in the preparation of alpha beta unsaturated carbonyl compound preparation and alkene preparation. Right. So this I have discussed. Justify the tributyl tin hydride behaves as a deoxygenating agent. So that means maybe you just mentioned the role of tributyl tin hydride uh, application. So in the deoxygenating agent, it means removal of oxygen. How the tributyltin nitride will act as a removal of oxygen from the substrate. That you have to explain with an example. With a suitable example, explain the synthetic utility of the organomercurals. Organomercurals means carbon mercuric Hg bond. How the carbon mercuric bond is formed and its application. Application means maybe a salvomercuration, demercuration, or maybe a oxymercuration, hydromercuration. Okay. Right, oxymercuration is nothing but a salvomercuration only. Then Gilman reagent, dialkyl lithium reagent is called a Gilman reagent. And here I am taking one more example. Predict the product with a reasonable mechanism. So that means what will happen when trimethylsilyl benzene is treated with the bromine. So you have to write the product. So discuss the Barton decarboxylation reaction. So the Barton decarboxylation means carbon dioxide half. It's a name reaction I have given just to look at it. Then explain with a suitable example. With a suitable example, discuss salvomercuration and demercuration. Salvomercuration means addition of mercury as well as a solvent to the double bond is called salvomercuration. Demercuration means, so when you are adding sodium borohydride, no, so that is called a demercuration. Peterson olefination means double bond. How the double bond is formed, more particularly with syn elimination. Syn elimination. So you have to take a eclipse form and then you have to show the mechanism with respect to the Peterson olefination. right? And then here formulate the products in the following with suitable mechanism. So what is happening here? Zinc. So zinc is a or organ. How it? I think you are aware about the Reformsky reaction. So sometimes they will explain. They will ask you what is Reformsky reaction. So we explain with an example. So Reformsky reaction means it is nothing but a reaction of alpha halo. This carbon is alpha. Alpha halo ester when it is treated with carbonyl compound in presence of zinc. Okay, so what will happen? Initially, there will be a reaction between the bromine, means this bromine is replaced by zinc. That means initially there will be a bond formation between this carbon and zinc, and then zinc will form a bond with bromine. So thereby it will convert electrophilic nature of carbon to the nucleophilic nature. So that means now at present alpha halo ester, this carbon is electrophilic nature, whereas there is a bond formation between the zinc and this carbon. That time this carbon act as a nucleophile. Then this will attack this electron deficient carbon. Okay, this reaction is called Reformsky reaction. So here the given example, okay, a Reformsky reaction is nothing but a reaction of alpha halo ester with carbonyl compound in presence of zinc. So with this, I will go to the next slide. You just look into this molecule. So just by looking into the molecule, don't be get afraid. So what you can do here, what is happening? AABN. AABN is a radical initiator. Once there is a radical initiated, so what will happen? That radical initiated one breaks this tributyl tin hydride. This tributyl tin hydride breaks this homolytic cleavage, forming a radical here. This radical again react with one more equivalent of tributyl tin hydride and forming a H. Replacement of this Br with H is H with H is the product. And then again organoselenium compounds is there. Okay, and then so next one, so what is this? Predict the product and discuss the mechanism of the following. Butyl lithium. So this question is not related to organo. Yes, it is related to organolithium compound. So what will happen? I think you are aware about this proton. So the proton present here is acidic in nature. So when there is a reaction of butyl lithium with this proton, so it will capture a proton and form an anion. And the butane gas is the one it will go out. So that anion, when it is treated with H plus, it will take a proton. So say product and reactant is same. But what will happen in presence of H plus? There will be a cleavage of this lactone. So that means this lone pair present on this can react with this proton, and there will be a cleavage here, and OH is obtained. That means hydroxycarboxylic acid is the product. And here, I think you are aware about the Simon-Smith reagent. So this is nothing but a Simon-Smith reagent. So insertion of carbon. This double bond is converted into cyclopropane. And that's what the thing. Right. So then Discuss the mechanism of the Peterson. So it is how the E and Z, more particularly stereospecific synthesis of E and Z is obtained. So that you have to take the reactant or the substrate in such a way that product means trans as well as cis compound is obtained. So I have given the example in a note. You just look into this. So Barton reaction, that's also given. So this I think it's a decarbonylation. So I think this comes under heterocyclic chemistry. And then discuss the preparation and reactions of organomercury. So mercuration, demercuration, salvomercuration, how it is useful in electrophilic substitution reaction, those things you can mention. So Gilman reagent. So formulate the Gilman reagent and how the Gilman reagent is useful in the reaction with the epoxide ring opening and how this is useful for alpha beta unsaturated carbonyl compounds, how it is reacting with the alpha beta. That means it will add to sp2 carbon atom, not the carbonyl carbon. And with respect to the epoxide, Gilman reagent means dimethyl lithium cuprate will add to lessendered carbon. So that you have to mention. Salvomercuration means addition of mercury and the solvent to the double bond is called salvomercuration. Demercuration means, so when it is a mercuric compound, when it is treated with the sodium borohydride, mercury will go out, will replace it with hydride. That is called demercuration. Then mention a method for the preparation of organozinc compound. How the organozinc compounds are obtained, that you have to mention. So with a suitable example, suggest any one method of preparation of organoselenium. Okay, how the organoselenium is obtained, that you have to discuss. So look here, here sketch the product and formulate a suitable mechanism for the following. In the first step, it's called what is called as oxymercuration. So that means mercury, it will form a bond with this terminal carbon atom and solvent will add to this carbon, oxymercuration. In the second step, the mercury group is replaced with hydride. Okay, so that is the second step is the demercuration. So that means in the first step, there will be mercury will form a bond with this carbon and OH will form a bond with this carbon. In the second step, the mercury is replaced with hydride. That is the product. And then give a brief account of the hydroalumination. So that means hydroalumination means it's nothing but a reaction of a substrate with dialkyl aluminum hydride. Carboalumination means reaction of a substrate with trialkyl aluminum compound. Okay, and then Peterson a double bond, how the double bond syn elimination is occurs. And these examples I have discussed. Addition of ethyl as well as ethyl group. Okay, and so this is a symmetrical triple bond, and ethyl will add to any of this center, no problem, and zinc will form a bond. I think you are aware about what is called as in presence of zirconium, stereoselectivity is there. So the obtained compound is what is called as a trans, that you can write. And here the zinc is replaced with the iodine. So thereby you will get a substituted product. In this case also, I think you are aware about one name reaction. So in this addition, initially there will be addition of ethyl zinc to the double bond. So more substituted one will add to ethyl group, less substituted one will add to, I think you are aware about one name reaction. So in that name reaction, it will act as a source of carbon. That carbon will add to double bond, forming a cyclopropanation. So here cyclopropanation, here iodoethyl will add to double bond. And here you can observe that this is a hindered carbon atom. This is a less hindered carbon atom. To this carbon, methyl group will add. Means methyl will form a bond with this carbon and there will be a ring opening. That is the product. And here you have to mention what is the reagent responsible for the conversion of tetrahydrofuran to this. So I think silyl ether, okay, silyl iodide is the responsible, trimethyl silyl iodide is responsible for the conversion of a tetrahydrofuran to diiodo butane. Then discuss the preparation of carboalumination. Carboalumination means it's nothing but a reaction of a alkene with trialkyl alane. So give the reaction of Barton-McCombie reaction. So I have given in the notes, just look into this. And I explain about Gilman reagent. And mention any two reactions of trialkyl halide as a protecting group. So trialkyl halide, I think this is protecting group. So this is not under organo mercury compound, organometallic related question. Explain how organoselenium is used in the synthesis of alkene. So maybe you can write down about the alpha, beta unsaturated compounds, how the synthesis. And here is they are asking particularly how the alkene is obtained from alkyl halide. So you have to mention the mechanism. Right. It is there in the notes, you just look into this. And sketch the mechanism of organoaluminium assisted hydrocyanation. So I am also given the hydrocyanation. So more particularly the beta carbon. Okay. So beta carbon attacked by cyano group. So the obtained compound is beta cyanoketones that you have to mention. Outline the mechanism of base catalyzed Peterson olefination. Acid catalyzed Peterson olefination is there, base catalyzed Peterson olefination is there. You just look into that. Mention any two reactions of organolithium. Reactions of organolithium you have to mention. Then describe the use of organoaluminum reagent in hydroalumination and carboalumination. Hydroalumination, it is related to dialkyl aluminum hydride. Carboalumination, it is related to trialkyl aluminum. And Gilman reagent, dialkyl lithium cuprate is the Gilman reagent. So this is about what is called as organometallics. So now maybe what you can do, you prepare for 403 internals. Okay, more particularly for the 40 marks. 40 marks internal, you can prepare and tell me which date you are going to write 403, and also you tell me which date you are going to write 404. That's called medicinal chemistry. Okay, so this is about the thing, but as usual you solve all these questions in a notebook, and that notebook you present it when you are coming to the college. And so now you prepare for the 403 internal, and also